Hey, Algebra 1, this is Miss Pathlin, and I wanted to go over the Quiz 9 practice quiz. So let's take a look at the first problem. Remember to always show your work. We can always give you partial credit if you at least show some steps, even if you get the wrong answer in the end. So please always explain or show your math work. Number 1, a company that manufactures candles tests the amount of time it takes for several candles of several different weights to burn. The results are shown in the table below. Construct a scatter plot of this bivariate data set on the grid below. Provide a title and a label for each axis. So always remember to label. And this time, it wants a title. I know that we haven't really asked you guys to do that in the past, but it is always good to put a title on your graph so that people know what it's about. So I'm seeing in the table we have candle weight ounces and burn time hours. So it's showing, based on the weight of the candle, how long will it take to burn. I always like kind of making it a question. So how long will the candle burn? That's going to be my title. You can make yours however you want, like candle burn time or something in regards to that. And then for the x-axis, remember your x is always that first column on the left. So we're going to put candle weight ounces. Always put what it's being measured by your unit of measurement, and then that would make burn time hours, our y. Okay, now we have to create our points using the data in the table. If you are required to number the graph on your own, in this case we don't, it's already numbered for us, but you know how sometimes you have to number it. Make sure to always be skipping the same amount of lines or not skipping lines, so in this case they're not skipping lines, and make sure your numbers are adding by the same amount each time. And I would just start with 0 to be safe, because not all of us teachers allow a broken scale. So from 0 to 3, 3 to 6, 6 to 9. The x-axis is counting by 3s. And then on the y-axis by 20s. And you can look at your data because we can see candle weight goes from 2 to 26. So we know we need it to go from 2 to 26. And I always tell my students go a little less than the smallest number and a little more than the highest number. So 0 to 30 is a perfect range for the x-axis. And then for the y-axis, we have burn times that go from 15 to 180. So again, starting at 0, that's a little less than 15, and 180 at 200 is a little more. So that is something to help. Always look at your numbers in your data to see how high you need to go. And then sometimes it's hard to graph this data because some of these points are really close together. So just do your best to get as accurate as you can. So like 2, 15. So if this is 0 and 3, I know 2 is a little closer to 3, a little more than halfway between 0 and 3. And then 15 about right here. All right, then 2, 16. See, we don't have a lot of space here, so even though my points are a little too big for that, but again, do the best you can given the graph and the data. 2, 18. Oh, okay, now if I go above that, we're just gonna go below. The one below is now 215, and then 216, and then 218. 320, that's right on the corner. 333, a little more than halfway between 20 and 40. 434, so 4 is going to be a little more than 3, and then 34. 435, again, just above that. 538. 540. 536. 1040. 1080, another 1080, so that's the same point, 1695, 16100, 1698, 22120, 22125, 22175, 26174, and 26180. So again, given that this graph and how small the space is, these points aren't 100% accurate, but I did the best I could. So do the best you can. And then using a straight edge, we're going to have to do B, draw a line of best fit through the data set on the grid. So when you're drawing your line of best fit, first you want to look, is it linear, quadratic, or exponential? In this case, this is looking linear. This looks like it's following more of a straight line. Obviously, it's not exactly on a straight line, but between those three types of functions, it's more linear. When you're drawing a line of best fit, you want your line to go through the center of the data points. So you want about the same number of points above and below your line. So again, do the best you can. A trick that I used to tell my students in the past was if you kind of draw like a bubble around it. So if you go around all your data points, and then you try to get a line through the center of that bubble. That's a way that could help you if you struggle with it. So I am going to go through it here. So I did my best, but again, kind of have about the same amount. There might be a couple more below the line, but I did my best. So we're going to go with this line. Now your line might be different, so you don't have to draw exactly like my line. Do your best as long as it's close to those data points and it's in the middle of them as you can. All right, then for B, you want to calculate the slope of the line by picking 2 points on the line. So we don't want to use the data points necessarily from our table and from these points I plotted. It needs to be on the line. So I like to choose points that are as close to being exact as I can. So I try to find ones on the corner of the grid. So like this one looks like it's on the corner. So that's at 21,140. And then this one up here does look on the line too. So I have 21,140, and then I have 27,180. And then to find slope between 2 points, m is our slope, and we do y2 minus y1, change in y, over x2 minus x1, change in x. Over delta y over delta x. Delta is the symbol for the change in. So then I'm going to fill in, so going back to this 21, so your first point, your lower point would be your x1, y1, and then your point above that is your x2, y2. So we want to find the difference, the change in those. So m equals, so y2 minus y1, 180 minus 140, over x2 minus x1, 27 minus 21. 180 minus 140 is 40. 27 minus 21 is 6. So then let's do 40 divided by 6. And I'm going to be rounding, so I get 6.666666667. So it doesn't tell us, always go back and make sure if it says to round to the nearest tenths or hundredths. So I'm going to just round to the nearest tenths. So here's a few of my decimals right now. And so when I round to the tenths place, I want to look at the hundredths. This 6 tells me to round up. So I'm going to round that 6 up. So my slope is about 6.7. Then D, show how to use your line of best fit to estimate the burn time hours of a candle that weighs 15 ounces. Illustrate your answer on the graph. So I still need to make sure I have my equation. If it says to use your line of best fit, this is asking you to use an equation from your line. So if our slope is 6.7, or if my slope of my line is 6.7, I also need to plug this into the equation y equals mx plus b, because it's linear. So I know m is 6.7. I now need to go back to my graph and look at what my b value is. So I was trying to have it start at 0 because a candle that's 0 ounces is going to be 0 burn time. Looks like it's a little off there, but it's close, so I'm going to go with 0. So my slope would be y equals 6.7x plus 0. Now, if your line starts at 20, then your y-intercept would be 20. So always look at where the y-intercept is for your b value. And I don't have to put plus 0. Another way to write this would just be y equals 6 7/10 x. And what that's saying is, if it ever asks you to interpret the slope, remember our slope is our change in y over a change in x. So if I create 6.7 as a fraction, 6.7 over 1, and I go back to my graph, y is my burn time in hours, and my x equals my candle weight. What this is saying that for each 1 ounce I increase my candle weight in, my burn time is going to increase by 6.7 hours. So remember, when you're interpreting slope, it is a relationship between both variables. You have to say, when one increases this much, the other increases this much, because this one is a positive correlation. So they're both increasing together. As the candle weight increases by 1 ounce, the burn time increases by 6.7 hours. So I always put it as a fraction and kind of label what each number represents, and that helps me to interpret the meaning. All right, then we need to still plug in 15 ounces. So if the candle that weighs 15 ounces, that's our x. So I'm going to plug it in for x in the equation. So y equals 6.7 times 15. And when you plug that into the calculator, you get 100.5 hours of burn time. Now it wants us to put this on the graph. It says illustrate your answer on the graph. So if my x is 6.7, my y is 100.5, so I need to put a point on the graph there. So I'm going to go to about 6.7. Oh, sorry, 6.7 is my slope. That's not my x value. 15 is my x value. Let me make that correction. So we plugged in 15 for x, not 6.7. That's the slope. Okay, so I go to 15. It should be close or on your line. So when I went to that on the graph, I was like, oh, that's way above my line. All right, so 15, 100. Oh, look, see, that point is on the line. So when you check it, it should be on the line since we're using the equation from our line. And then I'm just going to label 15 100.5 to show that I illustrated on the graph. All right, letter E, would you characterize the relationship? Now, this one, we made a mistake. It's talking about assists and number of rebounds, but what it really means is the candle weight and burn time. So between the candle weight and burn time. As a positive correlation or negative correlation, explain using mathematical evidence. Like I said before, this is a positive relationship. As the candle weight increases, so does the burn time, because our line is, if we look from left to right, it's increasing, it's going up. As the candle weight is increasing, so is our burn time. So positive correlation because as the candle weight in ounces increases, the burn time in hours also increases. Number 2, determine if each scatter plot below has no correlation, B, moderate positive, C, weak positive, D, moderate negative, or E, weak negative. Then match each scatter plot to its most likely correlation coefficient. All right, so let's first do the correlation as A, no, B, moderate, C, weak, D, moderate negative, E, weak negative. Okay, so the first one, I kind of like to look at all of my graphs just to make sure I'm choosing. Like, I want to go to this one right here. I know that that's going to be, and also this is more strong, strong negative correlation, but if you notice, we don't have strong on here. The highest level would be the moderate negative, so that's D. So I'm going to say this is D, moderate negative, and put a check mark there. And then looking at it, this would be a weak negative, E, check mark. This one, when the points are all over the place, that's no correlation. This would be A, and then this would be A. So now I'm left with moderate positive and weak positive. Again, I would say this is more of a strong positive, but moderate is the highest level, so we're going to give this one B, and then this one would be a weak positive, even though I feel like that's more moderate, but go with what your options are. With the options, those are the best and closest answers. Then we have to match the R values. Okay, so E was a weak negative. So let me go to my values down here. So we have, for weaker values, it needs to be closer to 0. Now, R equals 0 is no correlation. So I know that this one is going to go with my no correlation. So then for the weak negative, it's going to have to be a negative number closer to 0. So I have negative 0.70 and negative 0.49. This one's closer to 0, so I'm going to put this one negative 0.49. And then I know that this one is going to be the moderate negative. For D, R equals negative 0.70. All right, then I am left with my 2 positive correlations. Closer to 1 is a stronger correlation, so I know that this moderate correlation is going to be the R equals 0.75, and this weaker correlation is going to be the R equals 0.56. The best fit line for predicting average group size of deer herds as it is affected by the percentage of woodland habitat is given by the equation y equals negative 0.07x by plus 7.9. The correlation coefficient is R equals negative 0.45. A scatter plot of the data and the best fit line are shown. Identify the correlation between the 2 variables. What features of the graph support your answer? So when it's asking about correlation, it's saying just positive, negative, no correlation. So in this case, I see a negative correlation. As my percent of woodland increases, my average group size of deer is decreasing. So negative correlation because as the percent of woodland increases, the average deer group size decreases. So again, you don't want to just say because the line's going down. You want it to be specific to the data on the graph, so you really want to use your variables. If line's decreasing, your x-axis is still increasing. These values are still, look how these are going up. These points are showing an increase in the woodland. But the average deer size is decreasing and going down. B, describe the strength of the relationship between the vital and non-vital tooth temperatures. Use mathematical evidence to support your answer. Again, there's a mistake here. So this one, it's asking about the deer size and the percent woodland, between percent woodland and deer group size. So strength of the relationship, again, is it strong, moderate, weak? So in this case, notice how my points, they're not very close on. That's not a strong correlation. Going back to my correlation coefficient, I would say that one's more weak. So that is what I'm going to put for my answer, that there's more of a weak relationship. Notice how some of these points, they're kind of far from that line. They're not, and yeah, if your correlation coefficient is less than 0.5, that's on the weaker side. So I would say the relationship is weak as r equals negative 0.45 is closer to 0, and the data points are not all close to the line of best fit. C, identify the slope of the line. Interpret this value in the context of the problem. So remember to always go back to your information given. It gave us the slope of the line in the equation. Slope, if your equation is y equals mx plus b, your slope is your m value. So I know that that's negative 0.07. So the slope is negative 0.07. Not x. Remember, x and y represent points on our graph, data points on our line. So you never put x next to it when you're saying what the slope is. It's just that coefficient, that number in front of x. And again, I always make it into a fraction to help me. So if I have negative 0.07, and I always put it over 1, and then I go to my graph. Remember, it's your y over your x, your rise over run. So my y-axis is my average deer group size, and my x is percent woodland. So I know that for each 1% increase in the woodland habitat, my average deer group size is decreasing by 0.07, or negative, well, decreasing is negative, so it's decreasing by 0.07 each time. So that's what I'm saying. For each 1% increase in the woodland habitat, there is a decrease in the average dear group size by 0.07 or 7/100. Thank you so much for watching this video. I hope it was helpful. Let me know if you have any questions. Bye for now.